to use graphs to solve their equations. So we are using graphs to solve their equations. The graphing method.
We already started on this one.
Yes, I know. You guys took notes on this. We're going to go over it together to make sure you guys get it. Okay? Because you guys are kind of on different paces. So, we had previously talked about if you have an equation of a line, a solution is any of the points that fall on that line. Okay? So if a point falls on the line y equals 2x plus 3, it is a solution to that. Okay? When we start talking about systems of equations, what we're looking at is, two or more equations and how they interact with each other. So two or more equations in the same variables form are a system of equations. So if we have each equation has an x plus y, something along those lines, we have a system of equations. Okay? The examples below give systems that consist of two equations and the variables x and y. Abby, do you have a set of headphones that Bryce could borrow?
Bryce what? Bryce what?
Are they seriously
Yeah,
sure.
Who's calling Abby too?
Yes.
You don't know which Abby.
Okay. All right.
Don't give us
Stevenson, he's coming over. Okay. To solve a system like these, so to solve, Keon, sit. To solve a system, it's unlocked. Like these, you must find all ordered pairs, x and y. Really? Right here. All ordered pairs where x and y that make both equations true. Okay, so you're going to find where x and y fits in both equations. Okay, so if I say have two equations, the point 1, 2 has to be accurate in both equations. Make sense? Okay. So the first thing that we're going to do is we're going to solve the system by graphing. Okay, so example 1, we're going to solve by graphing. And we have two equations, 2x minus y equals 8. And the second equation that we have is x plus y equals 1. Solve by graphing. Okay? So if I have these two equations, does this look like a form that's easily graphable for you? Okay, can you can you graph 2x minus y equals 8 in that form? Maybe, but you might need to put it into a different form. Okay, so try putting them into y equals mx plus b form first if we're going to be graphing these. Okay, so put it into y equals mx plus b form. Go ahead. So I would have, I'm going to move my y over. 2x minus 8 equals y. Y equals negative x plus 1. Okay? When I have a line in this equation, it tells me two things, okay? From looking at this equation, what two things can I find? Okay, looking at these two equations, what two things can I find? Taylor?
Slope and y-intercept.
Okay, so I can find my slope and my y-intercept. What is my slope?
2.
Alright, so my slope is 2. What's my y-intercept?
Negative 8.
Negative 8, okay? So what I'm going to do is I am going to, on my coordinate plane, I'm going to graph the point of my y-intercept. She said it was negative 8. So I'm going to go 0, negative 8. Yes, you do have to do this. Sorry, my line is not exactly straight. Okay? So I graphed my y-intercept down there. Okay? I could plug in another point if I wanted to find it. How else could I find one more point? Ty? Good. Go up 2, over left or right 1. Okay. It's a positive slope. Okay? So I should have this line that looks like this. I'm then going to make my line as straight as I can. I'm going to extend this line as far as I can, and that'll actually help me get better results too. So I'm going to extend this line all the way through my coordinate plane. Okay. Now my other equation was y equals negative x plus 1. What is my y-intercept? Negative x plus 1. Okay, good. So I'm going to go to the point 0, 1. Okay, what is my slope? Negative x plus 1. So that was my slope. Okay, so it's negative 1 over 1. So I'm going to go what direction to get my next point? Good, down 1 to the right 1. Okay? And I'm going to make my line, extending it as far as possible to get good results. Okay. When I have my two lines, I see that they meet. Okay? Can anybody tell me at what point these two lines with these systems equations, where do they actually hit, Tanner?
3, negative 2.
Good, 3, negative 2. So in this case, 3, negative 2 is the only point that makes both of these equations true. Okay? If you look at the first equation, this line here, which one was this? 2x minus 8. Any of these solutions here make this equation true. Okay? The other line, any of these points on this line make this equation true. But there's only one point that makes both of them true at the same time. Okay? That's this point here where they cross. Okay, that's what we're going to be looking for in here. Is at what point do these lines cross and make both of these equations true at the same time. Okay? You can now check this. Okay, so we said the point 3, negative 2. Okay, we can check that into our systems right here. Okay? So if I solve for 2x minus y equals 8, as well as x plus y equals 1, I'm going to put in my x and y values. Okay, we said the point 3, negative 2. So I'm going to plug in 3 and negative 2 for my values. What's 2 times 3? 6. Plus 2 equals 8. Does 8 equal 8? Yeah, okay, so it looks good in that first equation. Now put it in for the second one. My point was 3 plus negative 2 is 3 plus negative 2, 1. Okay, 1 equals 1. Alright, so we see we can plug those points back in and check and verify those points work in both equations. Okay, we're going to see where they see where the graphs intersect. That is going to be our point that makes it. I recommend using a ruler or a straight edge for this. It'll give you a more accurate point than if you're trying to freehand. I also recommend using graph paper because it will also help you get a nice even slope and you can see where those points intersect. Okay, on mine, I was extending points and I went 3 or 4 in each direction, and I saw that, oh, okay, I'm double hitting this point and make sure my line goes through there. Okay, you're doing the same thing. Example 2. Same thing, solve by graphing. Okay, x minus 2y equals negative 6. X minus 2y equals negative 6. And the second one is x minus 2y equals 2. Okay, graph those equations. I'm going to start by putting them into y equals form. Makes it a little bit easier for me. both of those equations.
Yeah, it has to be if you didn't do the negatives on
Oops. So it's positive subs. My bad. Okay, when I graph these two lines, first off, when I put them into y equals mx plus b form, what did that tell you? That they are parallel, okay? They have the same slope, and they have different y-intercepts, which make them two different lines, but they are parallel, okay? So I graph them like this. Now, if they don't ever touch, what's the solution? There is no solution, okay? So for number 2, there is no solution because there is no point that makes both of those equations true at the same time. Okay, so number 2, there is no solution because they do not intersect. Okay, there is no solution. Okay, next one is example 3. Solve by graphing. Solve by graphing. You have the equations 2x plus 3y equals 6. And you have 4x plus 6y equals 12. Okay? 2x plus 3y equals 6. 4x plus 6y equals 12. And put both them into y equals form and graph. Alright, so I solved for y on each, and I got the equations y equals negative 2/3 x plus 2 and y equals negative 2/3 x plus 2. Okay, so what is this? Well, when I graph them, it's the same exact line. Okay, both of those lines look like this. Yes. Yes. So in this case, every point is a solution, and a line goes on forever, so it's infinite many solutions, okay? So this system of equations has infinitely many solutions.
So like,
That's to infinity, not infinity.
so there's like a lot.
So like this this point goes to the point infinity. So if you're trying to graph the point infinity, then it would be like this, but it doesn't also mean infinitely many. Okay? So this we have infinitely many. If it's the same line, every point is a solution. Both of those equations will work or both of those points will work in each equation at the same time. Okay, so here you have example 3. We have infinitely many solutions. Okay? All the examples that we did today show you how to solve these by graphing. Okay, so that's what you're going to have to do. Do very precise graphing. That's how you guys did graphing yesterday. So you can work on how to graph those lines. Okay, get those graphs down. The more accurate your graph is, the more precise, the more clearly you can see those points they intersect at. Okay, so just a quick recap of the graphing method. Okay. So steps of the graphing method are how it actually works. Okay. Based off the examples. To solve a system of linear equations in 2A variables, draw the graph of each linear equation in the same coordinate plane. Okay, so that's what we're going to do. So to solve a system of linear equations draw the graph of each in the same coordinate plane. Rules are, number 1, if the lines intersect, there is only one solution. Namely, the intersection point. So here, you're going to give me the point, the x and y coordinate, in which those two lines crossed. Okay? So if they intersect, there is one solution, and it's where those graphs intersect at one point at which they crossed at. Okay? Now, number 2, if the lines are parallel, there is no solution. Okay? They don't ever intersect. There's no point that I make both of those equations true at the same time. If the lines are parallel, there is no solution. And the last one, if the lines coincide, so for the same line, there are infinitely many solutions. Go ahead. two equations, if I gave you a system of equations, and I gave you two equations, and I gave you a point, okay? So I gave you the equations, let's say 2x minus 7, or 2x minus y equals 7. And I also gave you the equation x plus y equals 2 with the point 5, 3. Could you tell me if this point was a solution to the system? Okay, so if I gave you two equations and I gave you a point, could you tell me if it was a solution? Yes. Okay, I think you could, and there's two ways that I think you could give me a solution. Name me one way. Tanner?
Graphing it.
Okay, you could graph it. The second way. Good. I could fill in x and y, my 5 and 3 for both of them, and see if I get the same, if both equations work. Okay, so I could do 2 times 5 minus 3 equals 7, as well as 5 plus 3 equals 2. Okay, so 2 times 5, 10 minus 3 equals 7. 7 equals 7. That works. Looks good. Okay, my second equation, 5 plus 3, does 8 equal 2?
No.
No. Okay, is 5, 3 a solution to the system?
No.
No, because it doesn't work for both equations. Okay, so at this point, no, there is not one. Okay? Take a minute and try this one. You have the point negative 1, 4, and the points 4x plus 3y equals 8, 3x plus y equals 0. And if you get finished with that, there's one more I would like you to try. Oops, sorry. So try those two. So I gave you two systems. I give you a point. Is this point a solution to the system? These are the oral exercises on page 414. The numbers 1, 2, and 3. You guys need to do them both. Okay? Okay, does the point negative 1, 4, is that a solution to that system? No. Okay, when you plug in your negative 1 and 4 for your x and y values, you should get the first equation works, but the second equation it doesn't, because it says that 1 equals 0, and that is not true. Okay, the second point, is that a point to the solution?
Yes.
Sorry, the solution to these systems. Yes, it is, okay? Both of those equations work. Therefore, that point works for both those equations at the same time. Okay, do we have any questions about the graphing method? Okay, your homework for tonight is on page 415. 2 to 22 even.
We're not even gonna be here long.
Okay, well your homework that'll be due on Monday is 415, 2 to 22 even. I recommend doing it tonight though, so you don't have weekend homework. Okay? And while it's still kind of fresh in your head, so you don't have weekend homework.
Can I borrow another piece of